let's go. Okay, so what we're going to do is we're going to talk about like multiplying powers and then doing it with the algebraic. But in the notes, the ones in the notes are like the shortest version. So I'm also going to help you on some on the assignment today. Okay. So first of all, if you're going to multiply powers and they have the same base, there's a rule for that. And what you do is you keep that same base. Like this one says 12 to the fourth times 12 to the third. So if you're going to do that, you get to keep the base of 12 and you add the exponents. Here's why. All right. What this really means, 12 to the fourth power, I'm going to write it over here, means 12 times 12 times 12 times 12, right? That's 12 to the fourth power. It's not 12 times 4. It's 12 multiplied by itself 4 times, right? So this is 12 to the fourth. If I multiply that, so I'm going to put a multiply sign, by 12 to the third power, that's 12 multiplied by itself 3 times, right? 12 times 12 times 12. So altogether, how many 12s get multiplied by themselves? 7. So the shortcut is to keep the base and add the exponents. So the answer here is 12 to the 7th power. Now, sometimes you're asked to go one step further and then also tell what 12 to the 7th power is, right? But the actuality, try to type that in your calculator real quick. 12 caret 7. What do you get when we type it in? A big, huge number, right?
35 million.
Yeah. So a lot of times they just want you to simplify it and leave the exponent on it. Okay. So it says, write what is each expression you written using each base only once. That's saying that they still want a base number and a new exponent. All right. It is the same for if it's negative, only you have to keep the parentheses. Okay. So -5 with parentheses is the base. So we keep that base, -5 with parentheses, and we're going to add the exponents, even though it is a negative and a positive here, right? So -2 plus 7 is actually what? 5. So this is our answer. Yep. And here's why. Okay, I'll give you the why on this one. So remember, we know that a negative exponent, right? We just talked about this yesterday, moves the base and the exponent to the top or the bottom. Bottom, right? So if I were to rewrite this, the -5 to the 7th power would be on the top. So if I write that out, I would have this 7 times on the top. Okay, -5. Here we go. 4. This is, I write too big. 1, 2, 3, 4, 5. Ooh, uh-oh. Okay. Oh no. Pretend it's all in there. All right. And that's all on the top. 7 -5s. How many -5s would be on the bottom? 2. What do we know about the same numerator and same denominator? It equals 1, right? So this is like timesing by 1, right? If I do that, that's a 1. So can I just cancel it?
Yeah.
This is like timesing by 1. So could I cancel that?
Yeah.
How many -5s are left? 5, and they're on the top, so it's positive. That's why this works, okay? Do you need to do all this to show your work? No, that's why we come up with the shortcuts, okay? Somebody else a long time ago figured out that this works, and now we get the joy of, they call these properties, right? And the property I copied, we get the joy of using the property of that. If you have the same base multiplied, you can add the exponents. We get to do that. We don't have to do this all the way out, which is good because sometimes these exponents get really big. Okay. All right. Next. Sorry, I wrote on that, but this, I'll rewrite it so that we can tell the difference here. This says 4z to the 5th times 9z to the -12. Okay, so now what happens when we start throwing letters in there and numbers? So one thing to notice is that we have two different numbers, and actually those are bases as well. You can really write this as 4 times z to the 5th times 9 times z to the negative 12. They're actually all separate, aren't they? So what happens is if you have base numbers that are different, you multiply those. So we're going to multiply 4 and 9 to get what? 36. Those are different bases. And so we can simplify that. And then we have a set that is the same base. We have z to the 5th and z to the negative 12. And what did we just learn we can do when we have the same base? Add the exponent. So what is 5 plus negative 12? So we put down our base of z, and that would be negative 7. That's the answer. This is as simple as it will go. So you multiply unlike bases, and you add the exponent on bases that are alike. Let's try again. So this one's a little bit longer, okay? Remember, these are all separate. This is really 2 times a times 9 times b to the 4th times 3 times a to the 2nd. Okay? What do you think I do first now? Now that I've kind of showed you, Malcolm, what do we do first? Which numbers do you want me to multiply? And what else? And 3. These are all unlike. 2 and 9 and 3 are unlike bases, and they're all numbers, so I can multiply them. So 2 times 9 times 3 is going to give us what? 54. Okay, so that's going to be our new base number of 54. Now, do I have any like bases that are left? A and A. What's my new exponent? 3. Yes, there's a hiding 1 on that A. So 1 plus 2 gives me an A to the 3rd power. Those ones would go together. And then b to the 4th doesn't have any matches, right? So there's nothing I can add to it, but it does need to go on the answer. So you're just going to attach that to the end. This is the answer to that question. 54, a to the 3rd, b to the 4th. So far, so good. Okay, last part then today is multiplying these, but I would like to show you on the other page. So go backwards a page a second. I want to show you here first because it's a little simpler. So this leads us into multiplying in scientific notation, okay? So you'll see it like this, okay? 3 times 10 to the 5th times, because there's nothing between there, right? 2 times 10 to the 2nd power. You can really write this as 3 times 10 to the 5th times 2 times 10 to the 2nd. You could rewrite it like that. But we write it like this when it's in scientific notation most of the time. Now, here's the cool thing about multiplying in scientific notation. You can use the property we just learned. So 3 and 2 are not the same base, right? So what would we do with 3 and 2? Multiply. So 3 times 2 gives us 6, right? Now 10 and 10 are the same base, aren't they? So I get to actually keep that base, but we're going to write it in scientific. So we're going to use this time sign, keep the base of 10. And what do you think I do with these two exponents? Add them. So we have, this is the answer, 6 times 10 to the 7th power. You multiply the bases, keep the 10s because they're the same base, and add the exponent. All right, let's do it again. So without rewriting it this time, what do you think I do with the 9.6 and the 3.7? David, go ahead. Times them. So go ahead and do that in your calculator real quick. 9.6, we're going to multiply these times 3.7. 0.52? Okay. What do you think I'm going to do with this 10 to the 3rd and this 10 to the 3rd? First of all, what do I do with the 10s? I keep that base. What do I do with these exponents? I'm going to add them. Okay. And what do I get?
6.
Okay. That's not the correct answer. Somebody tell me why. From what we learned yesterday, why is that not right, Cameron? This has to be less than 10. Okay. So let's make it less than 10. Where would the decimal have to go, Ivan? It has to move back one, doesn't it? So I can rewrite this like this. I'm allowed to do that. 3.552. If I move it back one, I'm going to keep the times 10. What do you think that's going to do to this 6 exponent, Speciosa? It's not going to make a negative.
We're going to add one to it.
It's going to add one to it. It's going to make this a 7 because now to go make it in standard form, we have one more space the decimal would have to move out, right? So if you have to move, the rule of thumb is this. Here's the rule. If you move the decimal back one to make it work, right, you would add one to the exponent. Now, sometimes you'll do this out and it'll be too small. And you'll have to move the decimal this way. You'll have to go to the right one instead. What do you think is going to happen to the exponent? You're going to minus 1 from the exponent. That's right. Okay, so this is how you do it, right? Without anything else attached. But this is the questions that you're going to get about it. Okay, so go back. Sorry, I know I'm flipping back and forth here, but go back to this. What you're really going to see is story problems that have to do with scientific notation. The nice thing is, if you know the rules, they're actually really pretty easy to answer. Okay, so it says at 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. That's the mass. All right. So think about that. There's an ice cube of water. So at 20 degrees Celsius, it's not a cube of ice cube necessarily, but it's in like a tank. Okay. Each gram of water contains about 3.34 times 10 to the 22nd molecules of water. How many molecules of water does the droplet of water shown below contain? So there's the volume of the droplet, right? Okay. So what do we have to do here? This whole cube has this many grams. Every gram has this many molecules, right? And then this droplet, how many molecules does this droplet contain? What do you think we're going to have to do here?
You have to times the 9.98 by the 3.34, and then you get 33.332 times x
times 10
or times 10 to the 27th, but then the 3. There's supposed to be another 3 by the way.
Oh, is there 3 3s back here?
Yeah.
3.3332?
Yes.
Okay, so he's right. That's our first move, was we multiply this one by this one. But what about this guy? Do we have to multiply it again?
No.
Yeah, we do. We have to take our answer now and multiply it by this one. Okay, so I know there's something wrong with this right now, don't I? But before I do anything to it, let's multiply the third one. So we're going to take that answer and multiply it by this one. So we got, what do I multiply by 1.13?
33.
Yep, let's do that. So we're going to take this and multiply it by this. Okay, so 1.13 times 33.3332. I'm doing this times this, the 1.13 times the 33.333.
37.666516.
Okay, a lot of significant digits here, okay? And then times 10, what am I going to do with this exponent and this one? I'm going to add, what's the new one?
20.
20, right? Is this correct?
No.
What do I got to do?
I'll go back one.
Back one, right? If I go back one, 3.76666516 times 10 to the what power?
21.
21. We got to add one to that exponent. It's not that bad when you know the rules. Okay, that's it for the notes, okay? So what we're going to do is, did I get this out already? I did, right?
Yeah.
I highlighted some ones I want to do with you, okay? And then your assignment is to do the front side of this, the evens only. But I'm going to do some of the evens with you so that you know what to do and you're not scared and lost. Okay? Don't be scared. All right, that's it for video.